equations which involve the laws of indices. You need to apply the laws of indices to solve such equations. So here's a list of laws of indices. So you need to know these laws of indices so that you can solve equations which involve these laws. Then the first law states that when we multiply on the same basis, we just simply add the powers. Then the second law simply states that division on same basis, then we just subtract the power. Then this law, any number to the power of 0 or any letter to the power of 0 is equal to 1. And this law states that any number raising to a power of negative is its inverse or reciprocal, or we invert the number, we find the inverse of the number. Then this law says that a base raising to a power and multiply again by a power, the powers multiply each other. In this case, x to the power of a to the power of b is just a times b. This will get x to the power of a b. And this law, x to the power of 1 over a, it will become or written as a root of x. Then the last says a base to a power, having a power of b over a, and you can write as a root of x to the power of b, where b, we can look this another example. First things to read the question, guys, so that you can understand very well. 2 to the power of minus 2 multiplied by 2 to the power of 3, 4 over 2 to the power of 4 is equal to 2 to the power of 3. So the requirement of the question is to solve. We need to know the value of C. So we are applying the laws of indices. At the first part, we are applying the first law. Multiplication on the same basis, addition of powers. So we are remaining with 2 to the power of minus 2 plus C, right? Then division on the same basis, subtracting the power. So minus 4 here is equal to 2 to the power of 3. Since here we have got a same base, we have got in base 2. So we are going to take the powers. So we are taking minus 2 plus C minus 4 is equal to 3. So at this stage, we are just grouping the right term and solve for C. So we are going to take minus 4 and minus 2 to the right side. At the left side, we are remaining with C and 3 here plus 4 plus 2. Then we add 3 plus 4, we get 7 plus 2, then we get 9. So our final answer is equal to. Proceed, guys. Here we have got another example. 3 to the power of y is equal to 9 to the power of minus 2. Here we have got base 3 and we have got base 9. So in order to solve for y, we need to convert 9 to base 3. So here we are going to change 9 to base 3. We know 9 is 3 to the power of 2. So multiply again by negative 2 since we have got another power here. So we are remaining 3 to the power of y, then minus 2 multiplied by 2, we get minus 4. Since we have got same base, we are just taking the powers. So our y is equal to minus 4. Right. Here we want to solve for m. So we've got base 2 and 32 here. So the first thing to do is to know which base are you going to deal with. So we can convert 32 to base 2. We know 32 is equal to 2 to the power of 5. And of m. Since we have got same base, we're just taking the power. So our m is equal to 5. Yes, another typical question is here. 9 to the power of m minus 1, where m minus 1 is a power, is equal to 27, and the question requires you to solve for m. So you need to convert 9 and 27 to the same base. So the requirement base is 3. So we are going to change 9 to base 3 and 27 to base 3. Since if we have got same bases, we can solve for m. So we know 9 is 3 to the power of 2. So the 2 multiplied by m minus 1 is equal to, we know 27 is 3 to the power of 3. Right, so we are going to multiply this bracket, or removing this bracket by 2 here. Then we are remaining 2m minus 2 is equal to 3 to the power of 3. Right, since here we have got base 3 and base 3, then we are just picking the power. So we are naming 2m minus 2 is equal to 3. And we are just taking minus 2 to the right side so that we can solve for m. And we are remaining here 2m is equal to 3 plus 2. Then we add, we get 5 here. In order to find the value of m, we divide by the coefficient of m, which is 2. And here we are meaning the m is equal to 5 over 2. So this is the answer. And another example is 29 to the power of x is equal to 1. You need to understand, guys, how can you make the same basis here, 29 and 1. You need to know to apply the third law. Third law says that any number to the power of 0 is equal to 1. So we are going to substitute 1 by 29 to the power of 0. So that we have got same base. We change 1 to base 29. So if we change, we get 29 to the power of 0. So if here we have got same base, we are just taking the powers. So our x is equal to 0. You see here, solve the equation x to the power of 1/3 is equal to 2. So how to remove this 1/3 in order to get, or to remain with x here? How to remove this 1/3? So we can remove this fraction by its inverse. So x to the power of 1/3, I want to remove 1/3 so that I can get exactly the value of x. So I remove it by 1/3. Then here by 3. And we know 3 cancels, and remaining x is equal to 2 to the power of 3, which means x is equal to 8. So x to the power of 2/3 is equal to 4. Here is similar to this. So how to remove this fraction? We just remove it by its inverse. So x to the power of 2/3, I'm going to remove by 3/2. It's just the inverse of 2/3, 3/2. And here by 3/2. And we know here and here cancel, here and here cancel. We get x here, right? multiply by 3 to the power of 5, and we are remaining 3 to the power of 11. Right. Then we multiply here. It's 3 to the power of k is equal to 4 times 2, we get 8, multiplied by 3 to the power of 5 all over 3 to the power of 11. So at this right side, we need to apply the first law and the second law, which says that multiplication on same basis, addition of powers, then division on the same basis, meaning subtraction of the indices of the powers. So 3 to the power of k is equal to 3 to the power of 8. Under multiplication, we add here 5. Then under division, we subtract 11. So we are remaining with 3 to the power of k is equals 8 plus 5, we get 13. 13 minus 11, we get 2. So if we reach at this point, we know basically we are just picking the powers. So our k is equal to 2. And here's your question. Question A, 32 to the power of minus